Welcome to the Occupational Safety Leadership Podcast, episode number 300 with Bryan Haywood. Bryan has been a repeat guest. He's been the person I had on the absolute most. I've learned a lot from Bryan, and I really think he does a fantastic job of breaking down the OSHA regs and really saying, "Hey, look, this is what we have to do to keep people safe." I think he also does a great job of letting us know that the OSHA regs are awesome and everything, but it's just a starting point. We shouldn't think that folks are completely safe by just following these things only. There's a couple of them that are a little bit dated just because of today's modern stuff. They just have not caught up. So Bryan has done a great job on this whole thing. I wanted to bring Bryan back. I had a couple of requests to literally sit down and say, could you cover a complex lockout-tagout procedure and kind of walk through the process then? So what I'm going to do is do everything I can to not talk, have Bryan go through one that he did. And for me, it's really good because I do real small stuff. So even though there's going to be sulfuric acid and nitric and all that kind of stuff for my stuff, it's really everything is within probably 2 or 3 feet. So it's really easy to go back. It's really easy. Like we've already kind of set up the chemical lines to flush them. And I mean, we've kind of built in this stuff then. And so when I get a chance to look at what other people have, I really learn an awful lot out there because I have been pretty much pigeonholed into working in mostly chemical plants and labs. Everything was on a very, I can call the footprint big, but the machines were always small. So with that, Bryan, let's just go ahead and dive right in and take it away, Bryan.
All right. Thank you, David. So as we talked in the last one about complex energy isolations, I had shared this procedure I had done for a client a number of years ago, um, and they had a confined space near miss and decided they wanted to go the route of having a written procedure for isolating their mixed tanks. And this is an intermediate chemical manufacturer where they make intermediates for larger chemical processes. So they're doing a lot of blending and mixing. And these tanks are, I don't know, probably anywhere from 5,000 gallons, probably up to 20,000 gallons. So this is my format. I'm not saying it's the only way to do it, but I'm big on pictures and highlighting things in the pictures. And so this is mixed tank 34 as shown there in the picture. I put the department. Sometimes you get into these facilities and they'd have another mixed tank 34 in a totally different department, and that can cause a lot of confusion. So I make sure I specify the department. In the beginning of these procedures, I'll even have a site map showing where the area L is and in where tank 34 is. And usually the facility provides me those overlays for the facility so people know exactly which mixed tank 34 they're talking about. So, I put in all the basic verbiage about notifying all affected personnel, shutting down the machine, and then isolating all energy sources. And then there's a little warning there that this isn't meant to replace electrically safety related work practices. This isn't lockout for electrical work. This is just locking out electrical for like a pump or a motor. So the first energy source is the agitator. You can see the picture there. This is an agitated tank. The agitator has an electric motor of 480 volts. If you were to look closely at that nameplate on that motor, you would see it say electrical 480. So the electrical is the type, 480 volts is the magnitude. Um, Stop mixer using start-stop controls, turn off mixer on tank 34 disconnect on the wall under the steps. And then I give you the picture there of tank 34 with a red box around it to make sure you're actually getting the right one. It's labeled properly, which it wasn't when we first started, but we got the labels on there for lockout and for electrical work. And then we go to the next one. And again, this is a complex lockout because They want to be able to reclassify this tank into a non-permit. Um, and the You'll notice there the tank does have a fume scrubber line. All of these tanks have a fume scrubber line. It's just the way they were built and the way they were installed. And most of these fume scrubber lines are attached at the tank. At least they are for this picture, but they're not in use because the business does not run the processes anymore that had to be scrubbed. These are very, very low pressure, vapor pressure chemicals and do not create hazardous atmospheres. But for the purpose of the picture, for the procedure, we took the picture with the fume scrubber attached. We show close the quarter turn ball valve here on the below the connection, um, and then disconnect the hose and install the cap. And the cap is very similar to what you see here, where my mouse is at, next to it. And then you're going to lock the cap in place, which is here. And basically, it's difficult for a consultant to do these. David and I were talking earlier about, you have to go take pictures of every disconnect, every connection. And I would love to be able to take a picture with the cap on there, with the cap locked in place with one of the facility lockout locks. But when you're doing this over a 3 week period and you have several hundred pieces of equipment you have to go through, usually they're in service while we're doing our project, and it's impossible to get pictures with all of them shown as being locked out. So we do
Mhm.
the best we can with the images, with the circles and so forth. And sometimes we get a lot of questions about, closing the quarter turn ball valve here and then disconnecting the fume hose. And some people will say, well, why don't you lock that quarter turn ball valve out to disconnect the hose? And we apply the exclusive control remedy that the hose doesn't have any energy in it because it's dead. It's just hooked up for the picture here, but usually it's just got a cap on it. But we wanted to show the hose attached and how to disconnect the hose, because believe it or not, some of the hoses were connected during our project. Um, so we don't lock the quarter turn ball valve out, that right below, right on top of the tank or right below the hose connection. We close it, we disconnect the hose, put the cap on, and then we apply our lock to the pipe cap, because that's our actual energy isolation point, not the quarter turn ball valve. Now, if I was doing this on a process and that fume hose did have fumes in it and it was an actual fume scrubber, and there was a hazardous form of energy in it, then this would be considered a line break. And it would require me to have a permit, a line break permit. Some people call them LEOs, line and equipment opening permits, but we just call them line break for short. And that would require that quarter turn ball valve to be locked closed. And then using our PPE and so forth, we would disconnect the fume hose, and put the cap on there, lock the cap in place, and we would leave the quarter turn ball valve locked out as well. But on our confined space entry reclassification form, we wouldn't list the quarter turn ball valve as an isolation device. It was only an isolation device for the line break. The actual isolation that we're relying on to make sure we don't get reverse flow in that fume scrubber and we're putting fumes into the tank, which you can't even have the potential for a hazardous atmosphere in a reclassified space. We're relying on the pipe cap that we've got locked in place with the dog ears down and the lockout device over top of it. So it's two different isolations. One is to remove the hose. The other is to actually cap it so the hose can't be reapplied. One is for the line break to remove the hose, which is the quarter turn ball valve, the hose being disconnected and misaligned, and then the opening being capped off and locked closed. That is the isolation for the reclassification of the space. So I hope that makes sense. But
Mhm.
we took
Mhm.
we took some liberties in these pictures to try to make it look like all the other tanks. So someone If they came across a hose attached, they knew exactly how to handle it. Um, the next one is just the inch and a half water line to the spray ball inside the tank they use for cleaning when they're done with a batch. And that's in the yellow circle there. And again, we disconnect the hose, put the cap on it, lock the dog ears down, and lock the cap in place so nobody can attach a hose or pipe or any kind of fitting to it. And you could almost call them like a blind or a blank, but they're a metal pipe cap. We were using plastic. Well, they were using plastic, and I'm not a fan of plastic. So we now have metal isolation devices. They fit on plastic piping, but they're the actual isolation device is metal, which I believe has a higher degree of security and strength. So you're disconnecting the hose, install the cap, lock the cap in place here on the yellow. We go to the next energy source, which is number 4, and it's another half inch chemical water inlet. This isn't going to a spray ball. This is just for water addition into the mix tank. And so again, disconnect the hose, install the cap, and lock the cap in place within the yellow circle. We go to the next energy source, which is the 2-inch recirculation line. This line is basically just pumping the material out of the tank and recirculating it for quality purposes. They are also taking a quality sample off this recirculation line to verify that it's within the quality specs. But sometimes these tanks can hold material for days. And if they let it sit, it'll start to separate, and that causes quality issues. And so they have a recirculation line. And a lot of people would argue, well, if it's a recirculation line and the tank's empty, why do you go through all the effort to, make sure the recirculation line is isolated? Well, and simple, I try to keep it very clean and very simple for the operator. And when we train them on reclassifying a confined space, every single pipe, hose, tubing, ductwork connected to the space has to be isolated either through double block and bleed, disconnect and misalignment, or blinding or blanking. So when we start allowing them to leave the recirculation line untouched, it causes confusion. So we just are consistent across our practices. It literally takes them 5 minutes to do this recirculation line because you can see there, they're closing 2 block valves on the recirculation line. And the reason why is you also have a feed line coming into that. And so we don't have double block and bleed, but we do have double block. And we then break the pipe, the connection at the top on the nozzle in the green circle shown there over here where the pipe's going into the tank. We break the flange and we install a blind at the tank nozzle. So you're locking the pump out, and the pump has its own LOTO procedure because they do a lot of work on the pump where this is to reclassify the space. So you have to go pull the LOTO procedure on the pump, which is pretty simple. It's electrical disconnect. There's an inlet and an outlet and a drain on the pump. But you would lock the pump out, then you would close the quarter turn ball valve on the top of the tank here in red, and then you'd close the ball valve to the mixed room fill station here. And if there was a check valve in here somewhere, some people would rely on a check valve. I don't rely on check valves. You can't lock check valves in the closed position, and therefore I give them 0 credit in my energy isolation controls. So then we lock this valve out, and that is isolating it from going to the fill station. And then once we do that, the material's drained into the tank, and we break the line here again using a line break permit to install the blind, or some people would call it a blank, but technically it's a blind. And it goes there to make sure this does not. And if this piping was like a hose, you could disconnect and misalignment, but you can't disconnect and misalign rigid piping, whether it be plastic or metal. So that's why we installed a blind there. And that's the 2-inch recirculation line. Moving on to energy source number six is the 1.5 inch discharge line to the pump. Um, so again, we want all lines disconnected, misaligned, or blanked or blind, or double block and bled. Well, this one, we're going to disconnect the hose. We're going to close the quarter turn ball valve here in the red circle, coming right off the bottom of the tank. And we're going to disconnect the hose. Again, line break permit for this. Locking that valve closed, having the pump locked out, and we've drained it through the drain on the pump, on the drain between the two valves at the pump, and then we've locked the pump out. We're disconnecting this hose, setting the hose down, putting the hose cap on, and locking the cap in place. And that basically is your energy isolate. This is a complex energy isolation. You got to name all the energy types, their magnitude, the means at which you're going to isolate them, and the means at which you're going to verify zero energy. The way we have verified zero energy is all of ours have been disconnected, and either capped and locked or blinded. That the recirculation line had to be blinded. And we verify zero energy by literally when we open the tank, which has a manway on the side. That's also a line break permit. And we have the tank is isolated. We remove the manway and we verify the tank is empty and clean. And we know that we're at zero energy in the tank. We sample the atmosphere in the tank, even though you shouldn't have to sample a tank that you say doesn't have a potential for hazardous atmosphere, but I always do, just as a extra safety. We also continuously monitor the atmosphere in these reclassified spaces. We shouldn't have to, but we always do, just as an added factor of safety. Once you verified your zero energy, you followed your procedure, you have now reclassified this permit required confined space to a non-permit required confined space using section C7 of 1910-146. And that is a complex energy isolation plan.
Very good, Brian. Very good. So just to ask just a couple of questions, how often would they do this type of procedure? Is this something that's relatively common or only when something breaks?
Oh no, this is well, it I would say to enter it, it's probably a quarterly effort.
Uh-huh, uh-huh.
Some tanks would be more often. That's why they have the spray ball on most of them. They can hook up a solution and pump it in, and it's like a little sprinkler head inside the top of the tank, and it sprays a cleaning agent. It's like a clean in place kind of process, like you'd see at a food plant.
Uh-huh.
And they clean it that way usually, but it's an agitator, so every once in a while something happens to the agitator. The blades have to be changed out. The blades may have to be adjusted based on the batch sheet or whatever they're making. They may need more velocity than they normally have. So, but usually they'll tell you it's a quarterly effort probably to go in to the tank. So by having this procedure, it eliminated. So one of the things we did was we took the safety team, and there's 4 safety people at this facility, varying from yours and my kind of experience, 20, 30 plus
Mhm.
years to 2 or 3 years. And then of course there was an intern there just going to school. And so the plant manager and the plant engineer wanted to do a little, I don't know, like a little test. And so they had all of us go through and write out our energy isolation control plan for this tank to see if we would have 100% agreement.
Mhm.
And, I had to agree that I would have thought we would have been 100% in agreement, and we were not. Not only from some isolation points not being locked out because they didn't view it as a form of hazardous energy, to others being locked out with a single valve, not putting a bulk
Mm.
line or so that was sort of a telltale that's why the facility hired us to write procedures for all their vessels. So there was a consistency. And then, once the safety team understood the magnitude of this exercise, they were the ones that went through and then reevaluated our work to make sure we didn't miss something or were confused. Because typically we would have an operator or a maintenance person with us as an escort throughout the entire exercise. And they were the ones, telling us, here's the disconnect for this. And of course, if they weren't labeled, we made them label them. There was a lot behind this other than just taking pictures and writing the procedure. Making sure we had enough blank caps in the maintenance shop to fit over every one of those. So they had, you know, say they wanted to have 6 of these tanks locked out at the same time, and each one required 5 pipe caps. Do you have 30 pipe caps in the facility to be able to
Right.
do it all at the same time?
Right. Right.
So, I mean, we peel this onion down pretty far and make sure that when we leave, they're fully understanding and prepared to be able to do these energy isolations properly. And they had to go back and add the pipe caps to their LOTO training because not everybody knows how to, if you've unloaded trucks and you've worked with what we call the dog ears, where you're
Mhm.
clamping them down and strapping them, those are pretty simple, but I don't believe in common sense and safety. So they had never trained their people on how to apply those and to properly lock them closed so someone couldn't come by and take it off, even though there was a lock on it. But so they had to go back and revise their LOTO program and include those pipe caps as an energy isolation device, which they had never done before. So there's it they go into them maybe quarterly. But some of them they would go into, if a agitator blade fell off, which has happened before. Those are the kind of things. Anytime you have something inside the tank you have to fix, you're going to go into it on some frequency. But their driver here, David, was the near miss that they had, months before we showed up, and that's what really made the company sit up and pay attention. And that's why they went to this length to make sure all of these, and this was just the mixed tanks. There's storage tanks. I think in one of the pictures, you can see
It might be picture
neighboring,
two. I
you
think
can
that
see,
kind of shows it. Yeah.
you can see the neighboring tanks. I mean, against this wall is about 100 yards, maybe the size of a football field, and there's tanks all the way down. Some are mixed tanks, some are process vessels, some are what they call holding tanks, some are knockout pots. All of them are permit required confined spaces. All of them are usually handling low volatility chemicals, but nonetheless, they're contact hazard chemicals
Right.
such as caustic and things of that nature. And so it was a like I think it was a 4 week project um, to get them all done. But and then they had probably another week of going behind us and making sure we didn't miss a space or we didn't miss a point or something of that nature. Um, so it's a major investment for an organization to go this route to have these pre-prepared. They were trying to do it with what we talked about in an earlier episode using the energy isolation control worksheet.
Hmm.
And that was what we used in our little pre-test to see if everybody would fill it out right. And of course, you and I sort of joked earlier in one of our podcasts where it says, "What's the isolation device?" And everybody would put a lock, right? They didn't put a
Hmm.
valve or a blind or a blind. They would put a lock. Well, a lock's not an isolation device. A lock is what secures the isolation
Right.
device in place.
Right.
So it's those little things like that you've got to make sure people understand that a lock is, a lock should never show up on that energy isolation control worksheet. It should be a blank, a blind, a disconnect, a valve, something of that nature is an isolation device. And so that little test for the plant engineering manager and the plant manager was all the validity they needed that they were going down the right path to make sure they didn't have another near miss or worse, have a confined space accident.
Right. 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 Well, I'm just glad that nobody was hurt and that they took it serious. There's a lot of places that when no one's hurt, they chalk it up to, boy, that was close. We got to do better. And that's awesome, but then they don't really follow up with how we're going to do better. We just have to do better, you know? So
Yeah,
it's
yeah.
really good that they really took it serious. And I like your comment also on check valves. I have heard people say, hey, it's a check valve. It just cannot get by. And whether that's a chemical, that's water, that's whatever the deal is, you know, a check valve checks, you know, and to me, I'm like, I can't see it. I just don't.
Well,
I just don't feel good about having it there and saying, yes, I depend on that to work.
yeah, and
No.
there's no way to lock them. I've never seen a check valve that had a device on it that you could lock the check in the closed position. And since you cannot secure the energy isolation device in the safe position, I don't believe it's an energy isolation device.
Oh,
Um,
right, right.
the other aspect of it is most check valve manufacturers require their check valve to be tested or inspected on a 5-year basis. Some are even more frequent. And in process safety, we get into this all the time because a lot of codes require you to have backflow prevention.
Hmm.
Like if a hose was to fail, you don't bleed the whole tank empty where the hose failed, because the tank's going to go atmospheric when the hose fails, and everything in the tank's going to go to a gas and to come out right there at the truck unloading station. So you're required to have emergency shut-off valves with remote activation, as well as a passive engineering control, which is basically a check valve.
Hmm.
So you can't get reverse flow. It only flows to the tank. It can't go from the tank to the unloading station.
Right,
And
right, right.
when you're relying on them for those kind of things, then the manufacturer requires a 5-year test. Man, how many times have you seen a check valve in place and it looks like it's been there since World War II?
Exactly.
You know,
My whole
yeah,
life. Yes.
nobody's ever pulled it. I mean, and I'll be honest with you, when I started doing it in probably the mid 90s, when I learned this stuff, we went out and pulled our check valves on our bromine rail car unloading and loading stations,
Mhm.
and every one of them, the flap was completely gone.
Oh,
There was
man.
zero protection.
Yeah.
And
Uh,
they were probably 20 years old. And in bromine service, that's pretty nasty service. I mean, there was nothing there.
right,
So that's why you just never rely on a check valve in Lotto because you can't verify it's working and you can't lock it in its closed position.
right. Yep. Yep. And so the only time that I've seen a check valve come out of service is we happened to fix the tank for something else. And somebody said, hey, look, we got to go ahead and swap these out anyway. It's already open. It's already purged. Let's just swap it out now, you know?
Yep.
And and that's also because they happen to have it on the shelf.
Yeah.
I'm sure that if it was not on the shelf, they would have thought, oh, it'll break another couple of years. Like we'll be fine still, you know. I mean, something else will break in a couple of years, and then we'll worry about other stuff too.
Yeah. That's
Hmm.
pretty much that's just convincing yourself nothing's ever going to go wrong.
Oh, as humans, we are really good at that.
Okay. Yeah. Yeah. Especially the human that's responsible for the budget on that
Yes,
item.
yes.
They're very good at convincing themselves not to spend the money.
That's right. That's right. That's right. Well, Brian, it looks like we are bumping up on time. Could you take a couple seconds, let folks know how that they can find you out there? And I just cannot thank you enough for volunteering all your time, all these Fridays, sitting down, doing this whole thing, helping to educate folks and just making it better for folks. So could you take a couple seconds, let folks know how to find you out there?
Sure. Probably the best way, the most um, way most people know me through is my website, safetyengineering.net or safetyeng, SAFTENG.net. Um, and you can reach me through the contact portal on that page on the website. Um, I also have a Facebook safety group under the same business name, Safety Eng, and a LinkedIn group under Safety Eng. And the Facebook group gets pretty excited. We get some really good discussions.
Yep.
LinkedIn group's a lot bigger, but I think people are more reserved on LinkedIn, worried about making comments their employer may not like. For whatever reason, I think that people must think the employers aren't looking at Facebook because we get into some great discussions there. So
Right,
those
right.
are the two ways. And then, of course, you can email me at Bryan, Bryan, at safetyeng, SAFTENG.net. And I answer emails from just about any valid safety professional from anywhere in the world on a weekly basis. And I don't send invoices for phone calls, text, and emails. So it's all free.
Fantastic, Brian. And again, thank you so much for all the support, all these years. Thank you so much.
My pleasure, David. It's been great knowing you.
Yep, yep. And with that, let's go ahead there and wrap it up. This was episode 300. I want to thank all the folks for joining out there. This is really something that helps me at least feel good about giving back to that next generation. So I do everything I can to not show my gray hair and my balding scalp and everything, but I want to try and pass on a lot of this knowledge. I like to think that some of it's good. I'm sure that some of it, well, hopefully I want everybody to build on this and do much, much better than me. But I think it's a really good starting point in this whole thing. So and with that, I'm just droning on. So let's go ahead there and wrap it up. Everybody have a safe day.
Thank you, David.